Good afternoon, everyone. This is the pre-launch news conference for our OA6 mission, the Cygnus module to be launched atop an Atlas V rocket tomorrow night. And here to discuss the upcoming launch and the mission is Kenny Todd, the International Space Station Operations Integration Manager, Frank Culbertson, the President of Orbital ATK Space Systems Group, Vern Thorpe, United Launch Alliance's Program Manager for NASA Missions, Pete Hasbrook, Associate Program Scientist for the International Space Station Program at NASA, and Dr. Michael Roberts, Deputy Chief Scientist for CASIS, and Laura Godoy, the Launch Weather Officer for the 45th Weather Squadron. And we'll begin first with Kenny Todd. Kenny?
I'll say good afternoon, everyone. It's great to be here with you today as we get ready to go do this OA6 mission. It was literally almost a month ago that we finished up our joint operations with the CRS-4 Cygnus module. So first off, I'd like to congratulate Frank and the Orbital ATK team. It's a pretty phenomenal turnaround to support a 77 day mission for CRS-4 and then turn around a month later and be ready to fly again. So congratulations, Frank, and we're real excited and happy to be ready to welcome you guys on board again. At the end of the day, these resupply missions are critical. They kind of become our lifeblood on the space station, and so as we start to get into kind of this regular cadence of flights, it really does allow us to do more. It allows us to keep our crews good and healthy, and at the same time continue to do the critical research that we're all wanting to do, that we want to do with this program. So very excited about that. Since the time that the CRS-4 Cygnus left, we've been pretty busy on board. Since that time, we've brought 3 crew home, and with 44S return. And then this past Saturday in Kazakhstan, we launched a 46S and upped the crew back to 6 again. Which, when you think about the upcoming cargo traffic, it's good to have six crew members. So at this point, the ISS is in really good shape. Consumables wise, we're in very, very good shape. And so over the last couple of weeks, the crew has been preparing for this mission, doing their standard training activities leading up to the capture and berth activity. Tim Coper will be our prime robotics officer for this particular capture and berth. Tim Peake will be assisting in a normal set of backup duties. Once we get this Cygnus on board, we'll have our work cut out for us, about 7,000 pounds of cargo. All spread out across the different areas that we care about, our crew health supplies type of hardware, some EVA hardware on board, a lot of vehicle systems hardware on board, and equally as important is about 1,700 pounds of science and research that Pete can talk to you about a little later in the briefing. So a lot of good cargo coming up, so we're excited to get on with this mission. Once we get into that workload, we're right away going to be looking at some more visiting vehicle traffic. Next week we've got a progress exchange going on, a Russian progress exchange. We'll have one leaving, 61P, and 63P will launch a few days later. So again, the traffic just keeps coming over the short term here. And then probably in a couple of weeks here, we're going to hit a first for the space station program, what I consider kind of a milestone in that it looks like we're going to have an opportunity to have both of our CRS providers on board at the same time. We'll have a Cygnus as well as a SpaceX Dragon. So for those of us that have worked through this transition from shuttle into this commercial cargo service, it's really a neat thing for us to be able to see both of these vehicles up there at the same time. Again, a lot of work for the crew, but certainly a milestone moment for the program. So. But in the short term, we're excited about tomorrow night, getting this Atlas off the ground and getting Cygnus on its way, and look forward to welcoming CRS-6 on board.
Thank you, Kenny. And now to Frank Culbertson, the president of Orbital ATK Space Systems Group. Frank?
Thank you very much, and good afternoon to everyone. Vern, it seems like just a couple weeks ago we were here together doing this. It's only been actually about 3.5 months, so it's great to be back so soon and getting ready to launch on an Atlas and to take cargo to the space station. On behalf of Dave Thompson and the entire Orbital ATK team, I want to thank everyone here, particularly for all the hard work. We've had a lot of great cooperation and support from the Kennedy Space Center and its contractor team in loading the cargo and processing it, and from the ULA team. Thank you very much for all the great work in putting the stack together and handling our spacecraft so well. We had a chance to watch it roll out to the pad this morning. It's basically racing compared to what a shuttle did in the old days, but it got out there pretty quickly, even with the wind, and it looks magnificent. So we're looking forward to a spectacular launch tomorrow night. Night launches are always very exciting. I do have a brief video that I'd like to roll, and we'll take a look at some of the processing that we have accomplished leading up to this. This is a quick picture of the service module in process and in testing at our Dulles facility. What you're seeing here is a test of the solar array unfurling. This is an Orbital ATK solar array that is new to this vehicle. This is our second flight of that particular array, and it has worked very well. Processing the service module itself and preparing it for transportation down to Kennedy Space Center, down I-95, actually just a few miles from my hometown in South Carolina. All my friends were standing on the road waving as it went by. And then setting it up for assembly in the space station processing facility, and then moving it into place for mating with the pressurized cargo module. We had to load the module first, of course, similar to what we have done at Wallops. We loaded about 3.5 tons of cargo. Team worked really well together. Had to do a little bit of repacking, but sometimes you got to do that on a trip just to get it right. And it worked out well. Then we put it in the vertical, attach it to the service module. Very careful operation, very, very detailed, of course, but that went well with the support of the local troops. And then getting it ready for integration with the Atlas and moving it to the processing facility for that. Late load, which in this case is not that late in the flow, but it's the last hardware that we put in prior to closing the hatch and getting it ready for integrating with the upper stage. Putting the fairing on is one of the last things, and of course that prepares the spacecraft for its flight to the station, protecting it from the forces of the atmosphere and of course the weather effects leading up to the launch. So it's all gone very smoothly, and as I said, we're very, very proud of the teamwork here. Everyone supports this very well, but we all understand how important supplying the International Space Station is. One other item of note, we name all of our Cygnus spacecraft prior to launch, and this particular spacecraft has been named for Colonel Rick Husband, the commander of Columbia, who I'm sure many of you remember. Rick and his crew, of course, were heroes to all of us and did fantastic work on orbit before being lost during reentry. However, Rick was a member of a crew that went to the space station and was actually involved in the assembly of the space station. And so he is the first astronaut who has been involved in space station assembly to have his name associated with a Cygnus. So we're very proud that we could do that for Rick and for his family and for the memory of the entire crew. And Evelyn and two of her kids will be here tomorrow to watch the launch, and so we're very proud of that also. We welcome them. As I said, it's going to be very exciting tomorrow to watch a night launch. I hope everybody watching remembers to tune in for it. And Vern, we're very pleased with the way the flow has gone and all the good work leading up to it. And looks like the winds will be a lot better tomorrow night than they were last time. So looking forward to going on the first try. So thank you very much.
All right. Thank you, Frank. Now to Vern Thorpe, the United Launch Alliance Program Manager for NASA Missions. Vern.
Okay, thank you, George. Our United Launch Alliance team is thrilled to be here once again, one day before launch of the OA-6 mission with the Cygnus spacecraft. This will be ULA's second resupply mission to the ISS. As we talked a moment ago, we were here about 3.5 months ago for the OA-4 mission. That was in early December. We're honored once again to support Orbital ATK and NASA in delivering supplies, scientific experiments, and equipment to our astronauts on the ISS. This mission will be the heaviest mission that has ever flown on an Atlas V rocket to date. Total spacecraft mass is a little over 16,000 pounds. About half of that is cargo, as we've talked about. OA-6 will also be ULA's third launch of 2016. It'll be the 106th overall launch since ULA was formed. And that was about just over 9 years ago in December of 2006. Some more numbers. This will be our 32nd launch of the Atlas V 401 configuration, and it'll be the 62nd launch of an Atlas V in total. The Atlas that we're using for this mission is our 401 configuration, and it's the one that includes the longest version of our 4-meter payload fairing. We have 3 different lengths of that. We're using the one that's known as the extra extended payload fairing, and we had to go with that longest version fairing to be able to accommodate the Cygnus module. And because this is a 401, of course, that means we have no solid rocket boosters on this vehicle. Right now, I'd like to play a brief video that shows you how the major elements for this vehicle came together down here at the Cape. So if we could roll that. So this is the Centaur arriving back on January 23rd, and it came in its own special shipping container. We bring it down from Decatur, Alabama. It's about a 1-day trip from our factory there. Once we remove it from the transport container, we keep it in our Atlas Spaceflight Operations Center, also known as the ASOC, for some final horizontal processing steps and checkout. You can see it pulling into the ASOC right there. We have the ability to connect all the electronics even when it's in the horizontal position to sort of simulate what it'll see out on the launch pad, make sure we wring anything out before we take it out there. This is the Atlas booster coming off the Mariner. The Mariner is the ship that we use to transport rocket stages from our factory in Decatur, Alabama. Once we load it on in Decatur, we'll head up the Tennessee River, connect into the Ohio, then down the Mississippi, Gulf of Mexico, through the Straits of Florida, and up the coast here to the Cape. We can also use the Mariner to deliver rocket stages to Vandenberg Air Force Base as well. Once the stage arrives here, it goes into the ASOC for final processing as well. What you see here is actually the Centaur, which has been integrated with the interstage adapter and some other hardware. We do that sort of partial stack offline, and it actually saves us a lot of time when we put the vehicle on the stand. We put the booster up, and then we bring out that integrated Centaur stack, and by doing that, we can get the entire rocket up in 1 day now. That's one of many things that we've done in the last couple of years to reduce our processing time. And then, of course, the final step is to take that spacecraft. You saw it encapsulated in Frank's video. We bring it out here early in the morning. That was a week ago, the early morning on the 14th of March. And then during first shift, after the sun comes up, we'll hoist it up, place it on top of the rocket, and then we're almost ready to go at that point. That takes us up to about a week before launch. And that last shot there was what the vehicle looked like this morning before it rolled out. And now that you've seen how the vehicle came together down here at the Cape, I'd like to show one more video, and this will give you a preview of what to expect tomorrow when we actually launch it. So if we could roll that. Okay, so when that vehicle lifts off, it's about 194 feet tall. It'll lift off with a little less than 900,000 pounds of thrust. And with this configuration, since there are no SRBs, the first major event that you'll see is when that booster stage runs out of fuel, and that will happen about 4 minutes into flight. This is actual footage from the OA-4 mission that we launched in early December. You see that we're going to go out on a pretty northerly trajectory. We have to go into a highly inclined orbit, of course, to match the orbit of the ISS. And what happens is the ISS actually will fly over right about the time that we launch. And we basically catch up to it, get in an orbit that's a little bit below it, and then Orbital will take over and Cygnus will phase with the station over the next few days. So here we are about 4 minutes into flight. We shut down the booster engines when the fuel's gone. We separate. About 6 seconds after that, 10 seconds after separation, we'll light the Centaur engine for the first burn. In fact, it's the main burn for this mission. About 8 seconds after we light the engine, we'll jettison the payload fairing. And let's see, that burn is about just short of 14 minutes, and that'll put us into the low Earth orbit that we need to get into. Main engine cutoff that you saw there will happen at T plus 18 minutes, and then we'll separate the Cygnus spacecraft at about T minus 21 minutes, as you see right there. Now, after separation, we will coast for about, I think, 27 and a half minutes, and then we'll do another very short engine burn. And the reason we do that is to do a controlled reentry. So we'll actually bring the Centaur upper stage down. It'll impact into the ocean just south of Australia, and that'll happen about an hour and 10 minutes after liftoff. Once we finished with the mating of the Cygnus spacecraft to the launch vehicle, as you saw in that other video, we did some final testing. All that testing, that integrated testing, went very well. And we had our launch readiness review last Friday. All parties verified that they are ready for launch. We had the Air Force's 45th Space Wing launch readiness review this morning, and everybody confirmed that status at that meeting. And we rolled the vehicle to the launch pad just about 3 hours ago. So the vehicle is out on the pad, healthy vehicle, healthy spacecraft, ready to go. Final countdown operations will begin about 4:30 p.m. tomorrow afternoon. And the launch window will open at about 11:05 local time. Normally for a cargo mission to the station, you have an instantaneous launch window, but our team has worked very closely with the Orbital ATK team. And just like we did for OA4, we're actually able to support a half-hour window for this mission. Basically what we do is we have 5 discrete points. The way we fly the vehicle changes a little bit each time to account for the rotation of the Earth in between those times. And over the course of half an hour, we'll have 5 opportunities to launch in case we run into a weather issue or any other kind of issue. So that will open at 11:05 local time tomorrow. And once again, we're proud to deliver Cygnus and every spacecraft we launch for both military, civil, and commercial customers. In this risky and technologically challenging business of space launch, ULA will continue to reliably deliver our nation's most important payloads and critical capabilities to orbit. I'd like to say thank you again to all of our mission partners. That includes Orbital ATK, NASA, the Air Force, and the FAA, and our entire supply team that helped get us to this point. We look forward to a great launch tomorrow night. Thanks.
Thank you, Vern. Now to Pete Hasbrook, the Associate Program Scientist for NASA for the International Space Station. Pete?
Thank you. I'd like to thank all of you for joining us today and for all those who are tuned in with us today. It's my job to tell you a little bit about the scientific cargo on the Cygnus. It's going to bring important cargo to us to continue our scientific mission that we're already doing on the ISS. The Cygnus cargo includes a variety of payloads. As Kenny said, it's over 1,700 pounds of payloads, or over almost 860 kilograms of cargo, and that makes up about a quarter of the cargo that Cygnus is bringing to us. Now, the ISS is an international laboratory in space. It's a very capable and versatile laboratory. Not like a lot of the laboratories that you'd be familiar with on the ground, which may focus in one discipline or maybe a very narrow focus within that discipline. We've got a variety of scientific disciplines that we do on the ISS. We've got human research, we've got biology and biotechnology, physical sciences, we've got earth and space sciences, we've got technology development, and we've got education and outreach. So we've got a very broad spectrum. And in our history of the International Space Station Program partnership, across the partnership in over 15 years, we've done more than 1,900 different scientific experiments. We've supported over 2,700 different scientists around the world, and we've had 95 countries involved in our research activities. The research results of our work on the space station add new knowledge about our understanding of our natural world around us. They enable future exploration, as well as improving the quality of life here on Earth. Now, the Cygnus launch is going to bring supplies to existing experiments on station, but it's also bringing us several new and exciting experiments. If you were with us for the What's on Board briefing earlier today, you heard a couple of the good ones there. You heard about Sapphire, and if I could have the first slide, please. Sapphire involves a controlled, planned fire on board the Cygnus spacecraft. This is after it's finished its berthed mission, after it's unberthed from the ISS. What you see here is a view of the Sapphire. It's got about a 1 meter long fabric sample inside of it that will be ignited. It helps us understand the propagation of fire in a microgravity environment. It helps protect future crews and spacecraft. The next bit of science that you heard about today was some technology called the Gecko Gripper. It's a mechanical adhesion technology using van der Waals forces. It is an adhesive, just mechanical, nothing sticky. It's removable, it's reusable, and even best, it's reusable on many different surfaces over its life. The next briefing that we heard this morning was from the additive manufacturing world, or 3D printing. Now we will have a facility on the ISS where we can do 3D printing. We can replace parts that are lost or broken. We can create new parts that have been thought up and sent up configuration file-wise on the ground. We're also looking forward eventually to be able to print whole new hardware experiments for us. The next one that we heard about was called Strata 1. It's studying the behavior of regolith, which is the impact-shattered rock that makes up the soil-like material that makes up the surface of the moon, asteroids, and comets. Next, we also heard about the next wave of microsatellites that will be brought to ISS, some of which will be deployed through the Japanese airlock and then out through with the station arms. We also heard about some new microsatellites that will be deployed from the Cygnus vehicle after it departs the ISS. And so with all this, I've given you just a brief summary of these the briefings that we heard earlier today. I would encourage you to go back and look up on our social media the What's on Board briefings. You'll hear it from the scientists themselves. It's really exciting to hear how the scientists describe their science in words that you and I can all understand. And so we hope you'll agree that the science that's coming on ISS and is being done on ISS is adding knowledge to our world, it's advancing our exploration of space, and it's bringing benefits to those of us here on Earth. Thanks.
Thank you, Pete. Now to Dr. Michael Roberts, the Deputy Chief Scientist for our commercial partner at CASIS. Dr. Roberts?
Thank you, and good afternoon, everyone. So CASIS is the Center for the Advancement of Science and Space. We work in partnership with NASA to manage that part of the International Space Station that is a national lab. In similar ways to that the Department of Energy operates national labs here on Earth, CASIS operates a national lab in low Earth orbit. And our mission is to work in partnership with NASA to enable access to that national lab so that investigators from academic institutions, from commercial institutions, from government agencies, in addition to NASA, can have access to that research platform. As you've heard already, that platform can support a variety of different investigations that range from the utilization of the International Space Station as a launch platform. So as Pete mentioned, there's an opportunity to utilize the International Space Station for launch of small and nano satellites. Those are in partnership with an implementation partner called NanoRacks, which also offers opportunities for research investigations supported by commercial companies. And most importantly of all, to my mind, educational opportunities. So in addition to the NanoRacks satellites that will be launching from the International Space Station, there are opportunities for payloads that have been developed by middle and high school students, which will go inside of station to be operated there. We also work in partnership with research organizations such as Southwest Research Institute, which is flying Project Meteor. Project Meteor is a visible spectrometer that will be placed on board station that will enable scientists the opportunity to look at meteors as they impact the Earth's atmosphere from a unique vantage point that's offered by the International Space Station National Lab. Pete also mentioned the additive manufacturing capability that's going up to station. This is a very exciting new capability for station, and this demonstrates the ability of the International Space Station National Lab to function as a research environment and then translate the findings from those research investigations into manufacturing opportunities and to opportunities that may be of interest to commercial entities or other national labs here on the ground. The additive manufacturing capability that's going to be flown up to station is operated by an implementation partner called Made in Space. And what they are going to have on board orbit is the capability to offer additive manufacturing in the space environment to users from a variety of different organizations, including middle and high school students or commercial vendors who want to explore ways to utilize the unique aspects of microgravity to benefit 3D additive manufacturing in that environment. Thank you.
All right, thank you. And we're ready now to go for our weather forecast for tomorrow. Laura Godoy, the launch weather officer from the 45th Weather Squadron. Laura?
Thank you, George. Well, we're expecting favorable weather conditions for tomorrow night's launch window. Let's first take a look at the satellite image. As you can see on the image, the cold front that pushed through yesterday is now well south of the Florida Peninsula. The cold front now that's past us, we're seeing drier, windier conditions behind the front. You can also see on the satellite image that there's some upper-level cirrus clouds. These are associated with the jet streak. However, this should sag a little bit further south overnight. Also, the high-pressure center is currently over the Gulf states. However, that will continue to push eastward and build over the next 24 hours over the Florida Peninsula. As we look at the launch forecast, we're only forecasting a 10% probability of violation, and that is due to the cumulus cloud rule. We're expecting cumulus clouds to develop about 3,000 feet. However, we're not expecting significant vertical development. So we're not overly concerned with the cumulus clouds that will develop. And our wind shift will be, our winds will shift from today from the north to be southeasterly tomorrow. Also, you'll notice that our winds drop. They're about 30 knots today in the low 30s. However, they're going to be only gusting into the low teens tomorrow during the launch window. Also, we have observed seasonably cooler temperatures. However, for the launch window, we're expecting between 64 and 65 degrees Fahrenheit. And the low temperatures that we'll see tomorrow in the morning will only be about the 40s inland. However, over by the coast, by the launch pad, should only drop into the low 50s. And again, we're only expecting a 10% probability of violation due to the cumulus cloud rule. In the event of a 24-hour delay, we're expecting really similar conditions. We do expect to see the onshore flow to continue, and with that, we might see an isolated coastal shower. However, the cumulus clouds we're not expecting to, again, develop high in the atmosphere, so we're not particularly concerned with the with violating the cumulus cloud rule. So for the 24-hour delay forecast, we're expecting 20% probability of violation. And winds, again, will be light, only gusting in the mid-teens. So overall, I hope that you get out to see the launch because we're expecting favorable weather conditions. Also, it'll be almost a full moon, and so it should be a great night to view the launch. Back to you, George.
Thank you, Laura. We're ready now to take questions. We'll start here at the news center and then go to the phones and social media. You can also ask questions by going to hashtag #AskNASA. So we'll start here in the front. Bill? Bill?
Well, Bill Horowitz, CBS
Okay.
News. Thanks. For Kenny, we were talking before that you had a Soyuz last Friday, and you got OA6, Progress, and SpaceX all within literally 3 weeks, 4 missions, which is unprecedented, it would seem to me, in the space station era. Would you just talk about that, the complexity? I mean, it's almost like with these 3 flights, it's almost 12 tons of supplies going up, which is like a shuttle cargo almost with those. It's a lot of work for the crew and a lot of work for you guys to make that happen.
It is. It's a lot of work, but the reality is doing day-to-day operations on station, we're constantly working around pinch points, whether it's things we need the crew to do today versus tomorrow and the different activities. Relative to the vehicle operations here, you have some that are going to happen down on the Russian segment, some on the USOS segment. We really didn't have that many conflicts that we needed to work around in this short time frame to to deal with all these vehicles. We had a couple of things that we had to put a little extra effort in with our Russian colleagues, but we worked through that, and nothing outstanding that I know of in being able to do that. Relative to the volume of cargo, the reality is that over a period of time there, we didn't see a lot of vehicle traffic, and so getting our consumables back up to the point where they need to be is something that we've been putting a lot of effort in, and again to our providers here, both certainly our Orbital ATK, for instance, they've delivered in a big way here over the holiday season, and certainly here again with another mission. So we're going to be in good shape on consumables after this mission. We're in pretty good shape now, but this just will extend us out further towards the end of the year for some of those consumables that we like to keep our eye on. The majority of them are already out past the beginning of next year. Again, this just gets us a little further down the road on a lot of those critical consumables. As far as the SpaceX launch, again, bringing a lot of different type of cargo on that flight as well. And so I don't see anything right now that's going to preclude us from being able to work through those missions simultaneously. You're right, it will be a lot of work, and we'll have to get creative in terms of making sure that we don't put the wrong things in the wrong vehicles when they get ready to leave. That's something we're working hard and we're going to have to put some focus on because we are going to be moving a lot of cargo through hatches.
Marcia, go ahead, Marcia.
Yes, Marcia Dunn, Associated Press, for you again, Kenny. How long will the Cygnus remain at the space station? And how long will the Dragon remain? Because I'm thinking maybe you want that one to come back first, and how big is the backlog of stuff that needs to come down to Earth from
Sure.
up there?
Right now we're anticipating about a 55-day stay for Cygnus. But typically when we get into any of these CRS missions, we sort of commit to the launch date and about what the length of the mission is going to be, and then we sort of get into it, and if we have to go a day this way or that way, usually we've had some flexibility, and these guys have been awesome at working with us to make sure that we can get the right target date based on things that we have going on orbit. So, but we'll shoot right now for about 55 days, and at least off the pad here, that's what I'll tell you. As far as the SpaceX mission, we'll probably hold that in that 30-day time frame. We've got a full slate of things to come home in terms of what I would consider to be cargo that needs to be refurbished. Also things that we just need to have for failure investigation and so forth. So yeah, we'll have a full flight coming home with SpaceX 8 for sure.
Follow up.
How serious is the backlog up there?
I wouldn't call it so serious that we won't be able to clear it out in the next couple of flights. For the next couple of return flights, we'll be fine. A lot of times what we deal with is the big things, because there's in one of the Cygnus modules there's only in the Dragon there's only so many places you can put the big things, and like on SpaceX 8 we're going to bring home an EVA suit, and that takes up a lot of space. We've got a couple other big things that we got to keep our eye on as well to try to get down to the ground, but nothing that, again, we're kind of prioritizing that, and nothing that's given us, we're losing a lot of sleep over yet.
All right, any more questions here? Yes, right here.
Yes, Jared Hayworth with We Report Space. I've got a question for Vern Thorpe. Given the larger mass of the payload, can you talk a little bit about the decision to use the 401 variant of the Atlas versus one or more solids?
Yeah, it all came down to what the level of performance is required to make the mission, and because we're going to a low Earth orbit, we can handle the higher mass. If this was say a geosynchronous transfer orbit, which is a very common mission profile that we fly, spacecraft this heavy would have required a lot of SRBs to be able to do that. But it's really a combination of the heavier spacecraft plus the low Earth orbit gives us a performance level that a 401 can handle, and we've got a fair bit of performance margin left over even on this mission.
Just to follow up on that, assuming you did use the solids, would that affect your 30-minute window possibility, or would you still, say you did have a payload large enough to need that solid to go to the ISS, would that affect your 30-minute availability to launch, or would it narrow down to be more like an instantaneous window in that case?
I would have to defer to our trajectory folks to answer that for sure, but I think if this payload weighed enough that we needed one or two solids, I think we would still have quite a bit of steering capability. It's really the vehicle steering capability, the ability to basically have it every few minutes go to a different flight profile that it's going to fly, which enables us to do that. There's not a direct correlation between that and the number of solids on the vehicle, so we'd still have some flexibility.
All right, let's come right here.
Yes, Mark Gotch, Historical Space Imagery. I wanted to speak first off again about the incredible benefits that we all know the ISS has given mankind since NASA created it at its beginning of its inception. Could you tell me, since CASIS was created, what year was it created, and the valuable experiments and their benefit to mankind? What is the volume increase, not only by private individuals, but in general, in the amount of experiments that have been conducted in the ISS?
Thank you. Very good question. So the focus of CASIS, and to answer your first question, CASIS was created in 2011. In 2005, the U.S. operating segment of the International Space Station was declared a national lab. And CASIS came into creation as a result of a cooperative agreement announcement made by NASA. So the reason for creating an entity outside of NASA to manage the International Space Station was to enable opportunities above and beyond what NASA was going to be able to fund, or to engage in partnerships with other government agencies to increase the level of funding and access to the International Space Station National Lab as a research platform. So to date, I wouldn't look at it as an increase in volume, but sort of I would look at it more as a research shift in focus, so that now the International Space Station as a national lab is open for research investigations that run a broad array of research interests that are not only interest to NASA's exploration goals, but on top of that, also enable research themes that are solely focused on Earth benefit. So where CASIS has seen a lot of engagement and where the ISS National Lab, I think, has had the greatest impact to date is in a couple of areas. One of those is in protein crystal growth, which is a well-established area of research that NASA has supported, and there's been commercial interest before, but there's a growing market of research for drug discovery that can benefit from unique aspects of microgravity. On the upcoming SpaceX 8 mission, we also have a research investigation by Eli Lilly, Two previous missions used a rodent research model were sponsored by Novartis. So there's a considerable amount of interest from pharmaceutical companies who seek to expose and model organisms such as rodents to that space environment to understand the effects of microgravity upon bone muscle density loss and muscle atrophy. We've also seen a great deal of interest from companies who are interested in materials testing. So they're primarily interested in exposing materials to the research platform outside of the International Space Station that is accessible through the airlock in Kibo in the Japanese module. We're also seeing a lot of interest in potential applications for commercial manufacturing going forward. So the idea is not to use the International Space Station National Lab now as a manufacturing facility per se, but understand the basics of what particular advantages may arise from manufacturing in that environment, and then build that so that in the future, the International Space Station or perhaps commercial platforms that come after it can support a manufacturing capability in low Earth orbit.
Thank you. You're doing fantastic work. Thank you.
All right, let's come right over here.
Hi, Josh Jenner with the Orbital Space. My question is in regards to the Gecko Gripper technology. Is there any sort of timeline in place to incorporate it into the limited excursion mechanical utility robots? And could their use on the exterior of the space station reduce the number of needed EVAs?
I would say, as far as the second question, yes, there is a lot of potential for using it inside and outside the space station. And to help answer the first one, I'm going to cheat. We've got Aaron, the scientist, in the back, in the left side of the room over here. So you could ask him that after the briefing today.
Jason Ryan at spaceflightinsider.com, and I believe this goes to Pete. Pete, I was interested about Sapphire 1. We know that Cygnus is going to spend about 8 days on orbit after it leaves the ISS, and that it's going to be, the Sapphire experiment is going to be in its own package, but I know that they usually pack departing spacecraft, disposable spacecraft, with, you know, used experiments and waste products to burn up in the atmosphere. Are they still going to do that and just keep the two separate, or will there be some kind of mingling of the two? Give us an idea of the layout of what that's going to look like? Thanks.
Sure, it's a good question. We do try to fill up all of our departing vehicles as much as we can to take as much waste away from the station. The good thing about this Cygnus is it's so big, so it offers a lot of room. And the crew will be given instructions on how to pack cargo within the Cygnus. In that box that I showed you, there's an air inlet and air outlet. It does depend on airflow and fans. So the crew's going to be given instructions on how to obstruct that area.
Okay, James?
Thank you. George James, Dean, Florida today. First from Mr. Todd, talk about the great shape the consumables are in. Is there a point with this mission or the next one where you'll declare yourself fully recovered from the failures that happened? I mean, I know there's different measurements there, but with food or whatever the kind of the key one is there, or have you already hit that, or are we where we need to be?
Sure. We track the consumables very closely leading up to all the upcoming missions to try not to put ourselves in a position where that upcoming mission is going to make us or break us or cause us to have to think differently about how we consume on orbit. And again, I can tell you now in those critical ones that we keep track of, we're good out through the December time frame on the one that becomes the nearest pinch point for us. And then most of them are into next year. This just gets us a little further down the road. We're launching a lot of different things on this particular flight, a lot of spares and so forth. When you look at the consumables, it's usually adding a month or two on to what we already have. CRS-4, again, just left a month ago and brought up an incredible amount of cargo, and so we're in really good shape now. So, if bad things were to happen or whatever, we've got a good full flight program between now and the end of the year, multiple vehicles coming to station, and our consumables support out through the rest of the year. So I feel very, very good about the critical consumables. The research is something, again, like I said earlier, it's a little bit of the lifeblood, and continuing to have the research refreshed over and over through these different flights is very important to us. And so we rely heavily on these flights, but those critical consumables that keep the crew safe, we're in good shape through the end of the year.
Thanks again. Excuse me, Mr. Culbertson, nice to see the Canaveral Lighthouse represented there on your mission patch. Is this farewell for Cygnus from Florida, or what do you think is the likelihood of coming back down here for a launch, perhaps under CRS-2?
Well, this is the last flight for this year for this particular program. We have relationships on other programs with ULA, and so we'll be back in other ways in the future. However, it's really up to NASA in terms of what type of missions they order in the future under the new contract, and we've offered both Atlas and Antares missions, and it depends on what they need and what type of a delivery they'd like to have. So we're prepared to do both.
Hello, Kyle Brown with U.S. Launch Report. The CRS-7 was carrying up an international docking adapter, and with multiple capsules going to the International Space Station in the same period of time, what is the docking adapter procedure? Is it this? Have we replaced the international docking adapter, or are they going through different companies?
The IDA, the International Docking Adapter, really supports whenever we start flying crews to the International Space Station on those vehicles. We're gonna fly that on the SpaceX 9 mission. That particular adapter is going to be put on what I like to call the front end of the station, which is off of PMA 2, the leading part that flies in the velocity vector. So that's where that one's going to go. It's not a port today that we use for any of these cargo vehicles. So I'm not sure if that answers your question, but that's kind of where we're at. Today it's an open area of station. We haven't accessed it in a while, but that's where IDA 2 will be going whenever it comes up here this summer.
Let's go back right here to Ken Kramer.
Hi, Ken Kramer, Universe Today and Northeast Astronomy Forum. My question is for Pete and maybe Mike. You mentioned that the science is about a quarter of the cargo. I wonder if you could put this in context with the previous missions of what might be coming up. Is that typical? Is there a chance to put even more science on here? And for post after you undock, are you looking at more science on the Cygnus after it undocks, since you have a whole huge vehicle available? Thanks.
I'll take the first part of that. This amount of cargo may be a little bigger for us, but I would say it's in family for the amount of cargo that we want to fly in a Cygnus. It's been a big focus of the ISS program and our contracts to be able to fly as much as we can as soon as we can have the payload developers get it ready. We're working really hard on shortening that timeline from when somebody decides, hey, I'd like to think about flying something, to when we can get it in a vehicle and onboard ISS. So that part's going really well for us. You want to take the next part?
And you do even more in the future, a higher percent?
I think, yes, we could. I think the capabilities there with these cargo vehicles, we really are trying to drum up the business for the station and have anybody who's got good ideas to come forward, let us help you get to station.
And picking up on that point, the business is there. I think there's certainly growing interest in the use of the International Space Station National Lab as an innovation platform. The only limitation, the primary limitation that we have right now is crew time. That's a more pressing concern than up mass. On the life sciences side, down mass can be a bit of a concern. As I mentioned, there's a lot of interest in the rodent model for pharmaceutical companies. That's a relatively long lead item. It consumes a considerable amount of crew time and other resources to do rodent research experiments up there. But what we're seeing is a steady increase in interest for that. And I don't think we're going to have any issues at all continuing to grow that. There's continues to be a lot of interest in the International Space Station National Lab because of its unique position as an orbiting national laboratory, and the ability to utilize that platform as a observation post for Earth observation, and the ability to test new sensors, new configurations with crew access so that you can actually recover the sensors at the end and not only the data. That's a significant advantage to that environment. And then having the ability to utilize it from both an internal and external perspective is eye-opening to a lot of commercial companies in the United States that hadn't considered space as a research environment for them to test longevity or functionality of components or systems that they make in that environment.
All right, let's take one more question here, and then we'll go to the phones.
Yes, Mark Gotch, Historical Space Imagery. Another thought on docking. As we look forward to Starliner, and we look forward to Dream Chaser, we look forward to manned spaceflight, is the current docking facilities and hardware that are in place in the space station going to work with those type of craft, or will there be a difference made? And even further in this question, when they talk about refueling, will this be looked at sooner than later? Could you tell me that, please?
Well, relative to the docking for the vehicles, absolutely. The docking adapters that we're putting on with IDA 2 and 3, those were designed basically with a thought in mind of the vehicles that'll be coming. And in fact, we partnered, built ICD type documents so that it's clear what the docking standard is going to be, not just, across the partnership. And so that's been that's something from very early on that we needed to get everybody on the same page. We don't want to build something that people can't dock to. And so there was a lot of effort early on to make that before we ever started bending metal. So we feel very confident that moving forward as a program that we'll be in good shape and ready to support the visiting vehicles that are going to be coming to space station.
All right, let's take any questions that we have on the phone, and remember to hit *1 before you ask your question. Irene, are you still on the line?
We have Irene Klotz on the line. She will. You
I
now have
am.
an open line.
I'm right here. Thank you. Can you hear me?
Irene, you're loud and clear.
Okay. Thanks very much. I have two questions. The first is for Mr. Todd. Could you tell us, please, if there's anything flying up on the Cygnus that's relevant to the issue with the U.S. spacesuits, and in general, what's the status of that issue? And then for Frank, if you're able to give us a status on the re-engined Antares and what's kind of coming up between now and when that rocket will be ready to fly. Thank you.
Okay, Irene. Relative to the EVA hardware on the flight, nothing that's going to help us make any forward progress relative to our fault tree and what happened on the EVA back in January. A lot of spare parts that are going up. We're going to fly another fan pump separator, some, again, leg assembly, some other things, about a little over 400 pounds worth of stuff going up. So nothing that's that again would be of significant interest relative to the issues we've had with the suit. As far as the suit itself goes, the suit we refer to as 3011, we're going to bring that home on the Dragon here later this spring. And I think with that, we'll be able to get a little deeper into our fault tree discussion and run some tests with that suit and see if we can't get a little more clarity with exactly what's going on. With the return of the 44S crew last week, a couple of weeks ago now, we did get a little bit of stuff back. We got some water samples. We got the helmet absorption pad that Tim was wearing in the helmet to give us an opportunity to kind of take a look at the amount of water that he had there. So we're slowly starting to dissect these little pieces of data that we're getting from on orbit. But the reality is, until we get that suit on the ground, we're going to have some legs open on the fault tree that are just going to take a little bit of time. With all that said, if we had to go out the hatch this week or next week, I feel very confident that we could go do that. Obviously, our intention would not be to be using 3011, but what we did after the January incident was we sat down and we looked at all of the mitigations that we had in place prior to this event and said, did they work? Did we feel like that the crew was safe? Did we have all the operational scenarios thought through? And the reality is yes, we did. And there was an integrated cross-section of the community within the program and a little bit outside as well. And there wasn't anything that we said we needed to go do different. So from a contingency perspective, if there was something that were to go wrong tomorrow, I feel very confident that we could through our normal processes go execute a contingency EVA and not have any concerns that we couldn't take care of the crew. But certainly getting that suit back on the ground will help get us some more data, and we're preparing like we're going to be ready to go do these EVAs here in a couple of months when we get the IDA on board. So we're leaning forward and learning everything we can about the suits every day, and we'll keep working to get ready to go do these EVAs this summer.
And Irene, as far as return to flight at Wallops, it's basically been a three-phase or three-step process. The first phase, of course, was the great work the Commonwealth of Virginia and through their Mars organization in refurbishing the pad and getting it ready for operations. That's been completed. Then we had to test that system jointly between ourselves, NASA, and Mars to make sure everything was working correctly as it should be in preparation for launch operations. The third phase will be coming up later this spring, which will be a hot fire or test firing of the newly re-engined Antares vehicle. We have all the hardware necessary for that hot fire as well as for the first launch of Antares, which will come sometime this summer. The exact date will depend on NASA's need, and they'll tell us, we hope soon, when they would like to actually launch that vehicle. But we will be ready in early summer for a launch anytime that they need it. And so things have gone very well there. I really appreciate the hard work the team has put into returning us to flight, and we look forward to flying out of there and having a 2 launch site capability for the Cygnus, which of course the team has continued to operate very well, starting with OA4 and on now into OA6. And that mission, by the way, is OA5 that's coming up out of Wallops. Don't ask.
Thanks.
All right, any further questions on the phone? All right, how about on social media? All right, no questions on social media. Let's take a couple more questions back here and we'll wrap up. Ken?
Ken Kramer, Northeast Astronomy Forum. Yeah, we just had Scott Kelly come back from his 1-year mission. I wonder if you could talk a little bit about that. And have you seen some differences between the 6-year and the 6-month and the 1-year mission? I think he has had some experiences with itching and some other stuff. I wonder if you could talk about that. And when will we see the next 1-year mission? Because it's critical for the journey to Mars. Thanks.
Okay, well, Pete, do you have anything on the results so far? And I can talk then.
I'll take part of it. Scott did a great job, and Mikhail did a great job in their 1-year mission. We're really glad to have them back. Part of the 1-year mission investigations included the twin study, which was another area that we're excited to get data back there. That's each of those, the 1-year mission on ISS and the twin study, is only 2 subjects. So we're very careful. In fact, you can't really make conclusions out of just 2 subjects and apply it to the rest of us. Also, the fact that these are medical-related investigations, you won't see the type of details in the results that maybe we're all hoping to see down into the details. The station program is working with our partners. The Human Research Program does want to do additional 1-year missions. That's something that isn't just something one agency could go do, so we work that with our international partners. I know that that's being discussed at much higher levels than I'm privy to, but we all hope that we will be able to get another, 6 or 8 different subjects. That's really what it takes to get a good long-term investigation like that.
So that is Pete's right. I mean, we're having those discussions with all our partners, particularly our Russian colleagues. It's very important that we understand what level of participation they would like to have in it, and we'll be finalizing that hopefully in the near future and get us all on the same page, and we'll be passing that on.
Differences between 6-month and a year. Do you really? It seems like there might be some issue or not. What are you saying?
I'm sorry, I guess I didn't follow your question.
The difference between a 6-month mission and a 1-year mission. It seemed like Scott Kelly maybe had a few more physical discomforts with itchiness after the 1 year compared to his 6-month mission. I wonder is that real or not?
I wish I could tell you. I haven't personally been part of any of those discussions with him about what he's feeling in there, and so I couldn't hazard a guess on that one.
Okay, let's take one more question right here and we'll wrap up.
Thaddeus Cesare with the Utica Phoenix. I was hoping to hear more about the Sapphire experiment and where this data is going to be specifically applied. Safety measures, mission to Mars.
Yes, so the Sapphire experiment is actually, this one will be the first in a series that they want to do. There's at least 3 coming up on the Cygnus and another set of 3 after that to study different kinds of samples. The sample that was shared with us today is about 1 meter tall of cloth. As far as how that's going to help us, it's going to help us understand a large fire propagating in space. The experiments that we're able to do today, even if you look at as big a rack as we have, about this big as a phone booth, your chamber for combustion is very small, and so you're limited in the size and you're limited to some extent in the samples. But what we want this to show us is how does a fire propagate in a bigger open volume, and what would we need to be concerned about? Are there things that would surprise us? We think we understand fires to some extent in space, but microgravity, where you don't have convection and you don't have the warm air rising and cool air bringing in new oxygen, is a whole different environment. And so how many years it will take to be able to apply that to future spacecraft, I really don't know that, but it'll be factored into the designs that we're doing at NASA as well as what the commercial companies are doing for their designs.
All right, that's going to conclude our briefing, our launch coverage tomorrow night will begin at 10 p.m. Eastern Time, leading to a launch targeted for 11:05 at the opening of the window. So thank you very much for coming.